So here we have one question, quite straightforward, although it might look a little bit intimidating. Basically, you're given an equation with an x. It's got some trig in there. It's got some inverse trig in there. And they're telling you very nicely that there are 6 solutions, and it asks you to find them all. So the question is, can we find them? And can we find all 6? Now, the question is probably a bit more daunting than you might expect. On first glance, it looks daunting, but it's actually not that bad. There are obviously sort of various identities we could use that could make this a bit easier. But more importantly than that, you should remember that whenever you've got the inverse sign or inverse trig of anything, so inverse sine of anything, or inverse cosine of anything, or inverse tan of anything, remember, they're representing an angle. So what I'm saying here is this inverse tan of x is just some angle. Let's think of that as alpha. So we're really trying to solve for, well, cotangent of 2 times some angle alpha. And this cos inverse is cos inverse of the whole thing. So this cos inverse is basically, well, cos inverse of some angle, which we'll think of as beta. So, oops, I should get it around the cos inverse as well. So we're saying that this whole thing is an angle, beta. So really, you're trying to work out sine of 2 times some angle, beta, that beta is represented by this, is equal to 0. And then, of course, that gives you an idea of what beta could be. And then you're taking the cotangent of 2 times sine angle, and that's going to equal 0. Now, we could do it sort of we could do this in a very sort of rote way. But I guess cotangent of 2 alpha is something we don't really have direct identities for, and that makes it a little bit tougher. But it's not too bad, I guess, because cotangent of 2 alpha, I mean, if you think about this, cotangent of 2 alpha, you understand cotangent is just 1 over tan. So it's just really 1 over tan 2 alpha. Okay. That's fair enough. But we know what tan 2 alpha is. Tan 2 alpha, if you think of your identities, is just 2 tan alpha over 1 minus tan squared alpha. That's your identities from your double angle formula. So with that in mind, cot 2 alpha, which is the reciprocal of this, will just be 1 minus tan squared alpha all over 2 tan alpha. Okay, that's great. But I guess, what's tan alpha though? Well, if alpha is tan inverse of x, then tan of alpha, I mean, note, of course, that alpha equals tan inverse of x. Then tan alpha must equal x. I mean, that's the way it works. So we know at this point that cotangent of 2 alpha can be simplified as 1 minus x squared over 2x. So in other words, we've already got the yellow part, right? This cotangent of 2 alpha is this yellow part. All right. So we've got 1 minus x squared over 2x. Let's now rewrite this on the next page. And we've got sine of 2 times cos inverse of, well, cotangent of that we said was simply 1 minus x squared over 2x equals 0. Confirm. 1 minus x squared over 2x, that was the yellow part. So we've got a sine 2 cos inverse outside, sine 2 cos inverse outside, and that equals 0. Now keep in mind, we said the cos inverse of this was beta, so I'm going to treat that as beta. Okay. So we could basically do this with beta, but let's think about on the outside. You've got sine of 2 beta, we know sine of 2 beta is 2 sine beta cosine beta, as expected, because after all, we know that's what we, that's your double angle formula. So it's going to be 2 times, well, sine of beta, which might be a tad more difficult. Cosine of beta, though, is easy because, well, beta is cos inverse of 1 minus x squared over 2x. So you should be able to see that cosine of beta is just going to be 1 minus x squared over 2x. Now, sine of beta is probably where we will have to get out our sort of rote a bit. So if we think of this as beta, if you cosine beta, it's going to be 1 minus x squared. So that means that's 1 minus x squared over 2x. Okay, so 1 minus x squared on 2x suggests that this would be the square root of 4x squared minus 1 minus x squared all squared. So with a little bit of work, that's going to equal the square root of 4x squared minus 1 plus 2x squared minus x power 4. So it's going to be, well, 6x squared minus x power 4 minus 1. Now, keeping that in mind, the sine of beta is opposite over hypotenuse. Okay. So it will be 2 times opposite, square root of 6x squared minus x power 4 minus 1, all over 2x, times cosine of beta, which is 1 minus x squared over 2x. And remember that this equals 0. Sine of 2 beta is meant to equal 0. Now, this is a fraction on the left-hand side. So the only way that this equals 0 is if this numerator equals 0. But the only way the numerator equals 0, well, I mean 2 can't equal 0, is if this is 0 or if this is 0. And the only way the square root equals 0 is if the thing under the square root equals 0. So we've now really boiled it down to these two equations equaling 0. So let's do the one on the left first. That's x to the power 4 minus 6x squared plus 1 equals 0. This is a reducible quadratic. And it doesn't look like it's going to factorize nicely. So we will use the quadratic formula on this. So basically, you can treat it as x squared all squared minus 6 times x squared plus 1 equals 0. Hopefully, that's not too difficult to see with the practice on reducible quadratics we've done before, which means that x squared now must be negative b plus or minus the square root of b squared minus 4ac all over 2a. So that will end up being 3 plus or minus the square root of 8, which is 2 root 2. So x squared is 3 plus 2 root 2 or 3 minus 2 root 2. So just to be clear, that means we're going to keep our answers in exact form, but just to give you an idea, that means it's 5.83 or 0.17. So both of those are going to give you positive answers. So you can take two answers from that. If they were negative, then you'd have a bit more trouble to do that with three-note theory. So in other words, if x squared equals 3 plus 2 root 2, then x must equal plus or minus the square root of 3 plus 2 root 2. If x squared equals 3 minus 2 root 2, then x would equal plus or minus the square root of 3 minus 2 root 2. I'm just going to leave them in exact values, but certainly there's 4 answers there. Your other answers, of course, are from here. And that should be very clear what those answers are. That's just going to be x plus 1, x minus 1 equals 0. And it should be very clear at this point that the answers there are plus or minus 1. Meaning that your 6 solutions are x equals 1, negative 1, positive or negative of 3 plus 2 root 2, and positive or negative of 3 minus 2 root 2, giving you 6 answers to that question. Now, as the question is rather involved a bit, what we could basically then do, as usual, get into a good habit is check your answer. So what we have is we're seeing that sine of 2 cos inverse cot of 2 tan inverse x equals 0. We've got x equals plus or minus 1, plus or minus the square root of 3 plus 2 root 2, and plus or minus the square root of 3 minus 2 root 2. Do a quick check with your calculator, and you should find that that works. And basically, that's how you do the question.